Hello, folks. Welcome to Taste Testing Tofu. In this session, we're going to be talking about all of the wonderful things that you can do by actually testing your code instead of YOLO deploying. So first of all, who am I? I'm the author of Terraform in Depth, a book that I wrote this year, one of the first books I think that actually covers OpenTofu as well as Terraform. As some background, I started working in the operations world in 2005, and I've been doing it ever since. I had a high security focus in 2005 to 14, where I pivoted to AI because that was fun. I also have a ton of open source software, and I even wrote a book, Terraform in Depth, which you should be able to get as a discount from this conference. So we're going to kind of talk really briefly about what Terraform is. Now, I'm assuming, this is an infrastructure as code conference, so I'm going to assume there's some familiarity here. We're not going to go too deep. But Terraform and OpenTofu are applications that allow you to write code and then push it out to production to a huge variety of different vendors using providers, of which there are an absolute ton of them. This gives teams the ability to just control all of their infrastructure, store it in code, iterate using GitOps, all of that fancy stuff that we all know and love. The development cycle is pretty easy. Somebody desires a change. Maybe I need more machines. Maybe I need to change, machine types. Maybe I need to go and do a whole new feature. You go, you write some code, init, plan, review, realize you messed up, init, plan, review, do that cycle a few times, and then apply in your dev environment. Hopefully you're not deploying from your computer. Super simple stuff. You have data resources, you have actual resources, which I probably should have put in here. Data sources let you read-only pull stuff in, resources let you actually control stuff. You hit the buttons, you run Terraform plan, it does stuff, tells you how much you want to add. I'm trying to go through this part really quick because, you already all know this. All right, so now to the meat of this talk. Why should we actually test? What is the reasoning for doing this? What benefits do we get out of this? Now, I'm going to say for me, one thing we want to do is prevent this. When you don't test, when you just deploy things, you have no idea how that's going to end up. It could be a great deployment. It could be an absolute trash fire. Without tests, you don't have those safety nets to actually know, and so everything's a gamble. But one of my big reasons that I absolutely love testing is, like most developers, I'm super lazy. I absolutely do want to spend time doing things I shouldn't have to. And tests give me the ability to not have to worry about that kind of thing. I don't have to worry about outages nearly as much, so that's less work I have to do. If there's maintenance, I can see what my changes are, what they might break. When people make pull requests, I don't have to pull down their code and run it myself. I can use my CI system to see that the tests are actually passing. And if they don't, I can tell people to actually fix their stuff before I give a review. A lot of people skip testing because it's work, but it's an investment. Like, you put your tests in, and then later on, that saves you time. And it often saves you time very, very, very quickly. The other reason is compatibility. If you actually have a proper backwards compatibility project, you have a whole test suite with all of your functionality. If you go and you make a change that breaks your backwards compatibility, your tests will yell at you. You'll notice this. You won't just deploy something that breaks everybody else's code. Once this happens, you have a choice. You can refactor so you're not breaking compatibility, or you can tag as a brand new, not backwards compatible release. So you get options here, but you actually get forced to kind of make that option. You actually have to think about it, and you're not just deploying and breaking things without people noticing. I saved the most important one, I think, though, for last, and that's psychological safety. There have been study after study after study, which is the thing that keeps people happy at jobs, the thing that keeps them productive is psychological safety. If you're doing something and it triggers anxiety, you're going to be less likely to do it, and you're not going to want to do it, and it's going to trigger more anxiety. If you make it so there are guardrails in place, if you make it so there's testing, and you add all of those really nice things that make it so you're confident in your code, everything becomes less anxiety inducing. If I know my entire test suite passed, then when I hit that deploy button, I'm confident that the build is also going to pass. And so Psychological safety allows everybody to move quickly and actually enjoy their job instead of working at one of those companies where you feel like you're constantly putting out fires. There's also some other benefits in here. If you're using something like pre-commit hooks, you can catch errors before even pushing them. So if you're one of those people who doesn't want to have like things found inside of your pull request, fix it first. Linting and security can also help you build confidence beyond things just working, but knowing that you're following best practices and that you're, not deploying something that everybody is going to break into in 2 days. So all of those reasons are why teams should stop skipping the tests. I've seen it in a bunch of places where people just don't test their Terraform. And I'm telling you now, if you put those testing in place, you see a huge improvement. And there's a lot of low-hanging fruit. By that, I mean, you don't necessarily need to go and write a massive test suite to get started. If you already have modules with no testing, let's start with some basics. The first is built right into Tofu and Terraform is your formatting. Terraform's nice in a way that the formatting is built right into the system itself, which means that you don't have to fight over standards. You're just running Terraform formatting. It's a very simple command. You can run it to actually update things. You could run it to see if people have failed to as part of your CI. Never align these manually. Don't align all those manually. That's just annoying. Use the tools that are available. Validation. This is literally the simplest test you can do that's actually logical. Run Terraform validate or Tofu validate against a couple of configurations, and you'll see if your code can even run. If it can't run, then you've got problems. And again, this is built right in. You don't have to install extra tools. You just do this, and it gives you at least the bare minimum. I didn't spell resource with 2 C's. You don't have those types of errors. Now we get kind of into the fun part, though. Now we start building on those other things, and we look at things like linting. TF-lint is one of my favorite tools. It allows you to install plugins. Obviously you're going to want to use the Terraform plugin, but you also install plugins for your individual clouds. Linting will help you follow best practices, and it will call out problems in your code. So this way, you can see right here in this example, variable region is declared but not used. If there are unused variables, that's just sloppiness. So TF-lint can help you find that or make sure you're not introducing those new features. All right. Then there's security. And again, we're still hitting the low-hanging fruit here. Don't worry, we'll get to the bigger stuff. But security is this other thing. Terraform is for controlling infrastructure. Infrastructure is an area you need to be on top of security. There are 2 open source tools, Checkoff and Trivy, that you can use with not having to pay a penny to scan your code, scan your plans, and see if you're introducing any problems or if there are things you need to take into account. I like using both of them. I know some people just pick one or the other, but they're free. They're open source. And so there's really no reason not to use them both. Some of them might detect one thing. Some of them might detect another. And again, you're not paying any money. You're just getting a third-party look at your code to tell you if there are problems. I also wanted to bring up Sneak, and I had a little joke. Apparently it fell out of this. They didn't pay me for this. Sneak actually has a decent infrastructure as code tool. It costs money, yeah, but it gives you a centralized dashboard and it functions pretty well. I don't think it's required, but if you're in a larger company where you need to report this all back to, a centralized location or things like that, then a tool like Sneak can be helpful. But even just Checkoff and Trivy are absolutely phenomenal and will catch a lot of stuff. Finally, docs. This isn't really testing, but it kind of is. Documentation is really important. And with Terraform docs, you can automatically generate that documentation in some really beautiful ways. You can also, as part of your system, make sure your docs are up to date by having a check. If you're doing stuff and it's not being, and people forgot to actually document it, then this will catch that for you. But okay, so we've talked about what are the tools? How do we actually make these safeguards? We do that by automating it. I mentioned already once the idea of pre-commit. Pre-commit framework is awesome. You can control it by using something like the fantastic pre-existing plugin. You can build your own where you just kind of put in your own commands. Either way, the pre-commit framework allows you to run your test locally as part of your commit process, so you can actually be sure that you didn't forget to do it. I wouldn't recommend putting your full like Terra test in there because they will take forever, but at least put all of the low-hanging fruit. Add in some CI, automate this. Every time you have a pull request, every time you have a push, just run your tests. Again, if you do this with just the low-hanging fruit, you're already doing better than a lot of teams. You can also, and we'll get into how a little bit more that you run these, but you can also use the strategy matrix to test against every version. All right, test against OpenTofu, test against Terraform, test against the different versions of both of those. And so if you have a company where people are using both of these software, it's remarkably easy to just test against both and be happy with it. Your modules will work regardless of who's using them. Throw in some branch protection rules. You don't want people just bypassing your tests. Nobody wants you to just push to main. That's pretty problematic. And then finally, and I think this is really important, use a cookie cutter module. Put all of your stuff into a module. Everything we just talked about would be a lot of work if you had to redo it every single time for every one of your modules. But do it once, put it in a template, and then all you have to do is run a single command, cookie cutter, and I've got one already built for you. You're welcome to start off with that. And you get a template of your project with your GitHub actions, all of the different tools, make files, test structure. If you make it easy for people to do all of this stuff, then they're more likely to do it. So I highly recommend that every team should just fully embrace cookie cutter or other software project generation tools. Starting from zero sucks, and everyone's going to forget to do stuff. And if you have standards, codify your standards using something like this. God, which slide am I on? Where'd I go? I got lost. Okay, so now we're going to get into the actually testing your resources. So start with the theory, all right? No matter how you're testing, you're basically doing the same thing. You configure, you launch, you validate, you clean up. This is very important to make sure you do all of those steps. I like to use examples as test cases. So what I do is I create an examples folder, and then I put a bunch of different folders inside of that with all of my different use cases. We do that, and then you just test those use cases. It gives you both documentation as well as tested use cases and things that work. What should you test? Data transformation, string creation, regular expressions, dynamic blocks, basically anything that's part of your system. You also want to do the system functionality itself. Like if you're launching API endpoints, you're going to want to test those API endpoints. If you're launching a database, you're going to want to confirm that your system can actually connect to it. Avoid testing the stuff, though, that's already tested in the providers. Like, it doesn't make sense to just say, like, does this module create the, like, you're not testing EC2. You don't need to make sure that the EC2 resource works. That's already done for you. I'm going to also start talking a little faster to make sure I get through all of these. So testing in practice. This is where things get fun. IaC is different than a lot of testing. It's not like Python. You have three major problems: money, time, and trash. And what I mean by that is, when you're testing, you're launching infrastructure, and that costs money. Launching infrastructure takes time, which can end up spending, something like an RDS, 45 minutes. And if your tests fail in some way, it's often possible for you to just leave garbage everywhere that you then have to go and clean up. So testing with infrastructure as code has its pain points. You can help with some of this using concurrency. This will allow you to at least move a little bit faster, but you also have to keep in account that your concurrency means your rate limits against your APIs are an issue, and you have to make sure that you randomize some of these names so you don't get like two resources named the same thing. You also need to deal with timeouts. Like Go test has a timeout of 10 minutes, and so if you're doing RDS, you're just going to break it. It's going to go for 10 minutes, fail, and then you've got a database you need to clean up. GitHub Actions is a much longer timeout, shouldn't be a problem, but depending on your test suite, make sure you're paying attention to timeouts. Finally, for cleanup, what I do is I like to just blow everything up every night. I create a GitHub action that just every night blows up whatever environment I have. AWS has a AWS nuke tool. With GitHub, I think you just delete a project. But if you just completely wipe everything out and then you allow it to be triggered in another way, if all of your tests fail, you hit a button, you're good to go. So authentication, use OIDC. It's great. I'm not going to go into too much detail. Saves you a lot of time. I wrote a blog post about it. These slides will be shared, so you can go and find that, but it's just up on my blog. All right, TerraTest. So TerraTest, by the way, never mind. So TerraTest is a fantastic tool written in Go on top of the Go test framework. You can see here we've got a very simple example of it on the side where we include an environment variable to just allow us to switch between Terraform and Tofu. Go testing is very easy. TerraTest is built on top of the Go framework, so you just create your test functions, you run a script, and it tells you where you've passed or failed. A test with TerraTest always follows the same structure. You've got your imports, you've got your stuff to set everything up, you've got the place where you shove all of your variables in, you defer your destroy, so at the end of the test, whether it passes or fail, you clean up after yourself, init and apply, and then you just look at all of the outputs and see if they match, or run any custom code that you want, because this is in Go, so you can do that. Like I said, I like to build on examples. In this case, what I did is I just used one of my examples as the workspace. I just changed the Terraform directory to pull from there. This, again, gives you the ability to test your examples and use your examples as test things. Copilot is also very interesting testing, works very well for TerraTest, but it does have some problems. You know, it might not use the most up-to-date or appropriate options. So I recommend starting with your own structure and then just telling it to write the tests inside of that. All right, so Terraform and Tofu now have a native testing suite. Very, very simple. You have these run blocks, you have your command, you have your asserts, and you can change your variables up at the top. Problem is that you end up with version issues. If you're using like Terraform's latest version, you end up with a problem where you can't test against previous things. You know, if you've got a feature like mocks that you want to use, you can't do anything before that mocks version was released. And so it kind of ties you into having to use the latest and greatest and not being able to expand things to a variety of versions. This site, cani.tf, super, super useful to figure that out. For this reason, I recommend people still kind of stick with TerraTest if they're building modules for a lot of folks. Simple tests, as I've shown before, you just look at the output, you see if it matches what you want. But a cool thing is you can actually access values inside of it. This is something TerraTest can't do. This means not everything actually needs to be an output, and you could go really in-depth on testing things. You also have the ability to do mocks, which means you can mock resources, not have to create them. That in turn means you can just test faster iteration, not having to, like, if you're using an RDS database and you mock the database, you save yourself 45 minutes. Of course, there are limitations with mocks where you can only do so much. All right, now Copilot. You know, I mentioned Copilot with TerraTest. It's a little different with the testing framework. Unfortunately, it just really doesn't work. The models aren't trained on Terraform native languages. They just don't know it. And so when you actually go and ask, it literally tells you Terraform doesn't support traditional unit tests like other programming languages. However, you can use a tool like TerraTest. This will change over time. More people, more data will show up, people will train on it, and I imagine that you'll see Copilot getting better. But if you're really trying to Copilot all of the things, you're probably wanting to go with TerraTest, not with what am I saying here? You're probably not going to want to use Copilot with the native framework. All right, a final comparison here between everything. And I literally copy and pasted this from my book. And don't worry, we actually, I talked fast enough, but we'll have some Q&A here, so we're going to be good there too. So on the language side, like obviously TerraTest is in Go, Terraform testing framework is in HCL. There's a lot of people who really want to go on the HCL side because they're scared of learning Go. But I will say that learning Go purely for testing is also pretty easy. I wouldn't suggest that that's the biggest blocker. The fact that the Terraform, that TerraTest is older means that there is a lot more support, a lot more documentation, tutorials, all of those fun things. And with Go, yeah, you can break out of the framework a lot easier and write more complex tests. The big thing, though, I really want to hit on this flexible versions again. TerraTest is decoupled from Terraform, which means you can run any version of TerraTest against any version of Terraform. As a result, you can just test a lot easier, have all of your test suite work with all of the different ones. And so that's kind of like the big stuff. I apparently talked fast enough so we can kind of dive into things. I've got the code here for folks, and I'm going to hit the little button so I can see QA, or if somebody wants to, lots of questions. I don't know how we do this if somebody would...
Hey, Robert, I can help facilitate with you. Yeah, there were some great questions that came through. Great talk. Thank you very much. All right, so we'll start here. With a question that came early on where you talk about pre-commit hooks, a little bit of a pain to distribute and enforce. Any good recipes for that?
Yeah, so the pre-commit framework helps with the first part, the distributing part. Using the and for context for other people, part of the reason that pre-commit hooks are hard to push out is because they are code that runs every time you do an action in Git. And it would be very, very dangerous to have a bunch of arbitrary code inside of a Git repo that ran when you made an action. So if you cloned it and there was a hook and then it would start copying credentials or things like that, it's very bad. So instead, what most people do is they use pre-commit hook framework, the pre-commit framework, which allows you to define your pre-commit hooks in YAML, and then you just run one command, pre-commit install, and it will install the hooks locally for you. This allows people to review them to ensure that they're working well and that they're not a security issue before they actually enable them. That helps with the distribute part because that file lives directly inside of the repository. Enforcing is another matter. Other than socially, there really isn't a way to enforce that people actually use it, which is kind of sad, but also, it's there for reasons. So yeah, unfortunately, enforcing isn't really an option, but that's also why, you never rely on the client side stuff. You use your CI systems to actually run these tests as well. Pre-commit is really just to prevent somebody from accidentally committing something without testing, but once it gets up to GitHub, you should also see if it failed there and just not bother reviewing the pull request until they fix the problems.
Great. So I will share this question here from Katrina. What are your recommendations on using Terraform OpenTofu test framework versus Gruntworks Terra tests?
So I'm still using Gruntworks for most things. And the reason I do that is for the reason I've already addressed, which is the versioning. I like my test suite decoupled because a lot of the work I do is for modules that are being distributed across a lot of different versions of Terraform, which means I need to test against a lot of different versions of Terraform. And so I can't use mocks to test in 1.6. So if my test suite includes mocks, all of a sudden I no longer can test 1.6. And so that's why today I still use TerraTest. I do believe, though, that this is going to change in the industry over time as the native test framework stabilizes. Because if we go 3 years into the future where, there's not a lot of new features because everything kind of works, we'll end up in a place where there's no real reason not to, because people are going to drop some of those older versions for testing. So I'd say that I would start with TerraTest in a lot of cases. But I will, again, bring up the fact that there are some things you can do in the native test framework, like that mocks, which can allow you to do things like test a lot of regex against certain patterns or things like that. So there might still be some places for that for some specific use cases.
Okay, great. Here's a question here on OpenTofu. So I know that OpenTofu is basically a Terraform fork. It is a Terraform fork. And can we imagine using it in a professional context where Terraform is not yet in use? Is it the same for a company to choose Terraform or OpenTofu in the next few years?
I see absolutely zero reason why people can't use OpenTofu today. I use OpenTofu every chance I get, from a legal standpoint, from a support standpoint, from a community standpoint, from a developer standpoint. I think it's a mature, viable product with backing of multiple companies, part of the Linux Foundation. I honestly would recommend that people start with Tofu. I feel like it's a project that's moving faster. It takes user experience into account more. It actually, I've had issues where I've gone into the Slack channel, brought up problems, and then they've actually fixed them. Where I've had open issues on the Terraform repository for years that are probably never going to be touched. And so I think that Tofu is honestly, in many ways, the more mature product, despite there being still some issues around the ecosystem. But I'm also really confident that those things around the ecosystem are going to evolve much faster and be like way cooler than they would otherwise. Like the OCI registry for Terraform modules and providers is just really cool. Just very, very cool. And being able to see these incredibly useful things. We're not seeing the same kind of movement in the core Terraform project. So my opinion is Tofu forever, which is why I named the talk after this. Instead of like taste testing Terraform, it's like eating dirt.
It was catchy. It is a catchy title. I do like it. All right, here's another one on Terraform Tofu and TerraGrunt. Do you use TerraGrunt or another framework around Terraform or OpenTofu?
Yeah, I use TerraGrunt quite a bit, but I've also done other things in different companies. So in my experience, I have used, I don't know, whatever they're calling Terraform Cloud this week. I've used Spacelift, which I've been a big fan of. I've experimented with M0, which I've also been a big fan of. I've even used Scalar, which has some really great benefits, but I've also used TerraGrunt running out of GitHub Actions. And I think these are all viable, and it depends on the team's need, like what you negotiate with a vendor. But I think for most people, starting with TerraGrunt and then using it with GitHub Actions is a great way to start. I think as your deployment patterns mature, though, there are benefits to using a full-fledged continuous delivery tool, continuous deployment tool, whether that's kind of an open source one or a vendor-based one. And I will plug my book a little bit. I actually, in my book, go over all of the different vendors and my opinions about them in the CD chapter, including TerraGrunt, some of the open source stuff, and some of the vendor things.
Great. There's some good banter in the chat. It's pretty good. All right, let's go to this one, getting back down into some of the things you were talking about early on. So quite often Terraform validate shows green, but actual deployment fails due to things provider cannot predict. How would you narrow this gap?
So, I mean, this is really validate is your code syntactically correct? Wow, I'm gonna need to drink some water and try that again. The thing is, where you fill those gaps is with TerraTest or the native testing framework. This is where those come in and become really important because they actually test the real world and actually using those providers with the use cases that you want. It's also why I still in this day and age recommend having a staging environment as well that's as close as possible to your primary environment. So that way you actually can see what a deployment would look like before you do it in a higher stakes area. And yeah, I want to agree with that statement. Some providers really do have poor validation. But remember, a lot of those providers are also built in, or open source rather. So you can go and push out changes to them. And the internal validation system, like the schema system for providers, is pretty good.
Great. Yeah, we've got a 1.5 minutes left of this session. We do have quite a few questions, but we've saved these, and when we do there's a Q&A session in the afternoon, we can go through some more of these. Let me surface this one. So early on, you were talking about kind of the psychological impact and that the exact anxiety that comes with it. Have you used any AI tools or workflows to help reduce that impact?
Oh, you had to hit with a heavy one to end. Yeah, no. So, my field is AI. I do Terraform and I talk about that, but I'm an MLOps person and I use Terraform in an MLOps world in a lot of cases. So for me, AI is mostly caused anxiety and increased the psychological problems. But that is kind of where I am. I find AI is useful in some places, not useful in others. I don't recommend writing Terraform with AI yet because I found that it does a lot of things that, using old providers, using old things, but I'm hoping that this will get better. I have found things like CodeRabbit and like code reviews to be pretty useful. So integrating that as kind of like a second pair of eyes into your pull request process is pretty good. But otherwise, I would say that this at the moment is not helping me reduce my anxiety in any way, and
Yeah.
maybe doing the opposite in some ways,
Yeah,
especially
maybe
as
it's an
people over
overload.
rely on it. Yeah.
Yeah.
And as mentioned, we've only got 9 seconds left, but we have an entire talk coming up that is nothing but people asking me questions and getting answers. So if yours wasn't answered here, just join the talk and we'll talk more.
Great. Thanks, Robert.